So purity test, you're basically going through a set amount of seed and trying to divide that into pure seed and everything else. So everything else would be any other types of seed you might find, and inert matter. So inert matter could be soil, insects, broken pieces of seed that aren't going to germinate. And basically the farmers use that to try to help them plan their planting for the year. So, you know, they have sophisticated calculations now where they know exactly how many seed they might need to plant on an acre, but if they're buying a bag of seed, they don't know necessarily how much seed is in that unless there's an accurate label on that. So if they're buying, say, a 50-pound bag of seed and it's 99% pure seed versus 80% pure seed, they're going to be getting a much different amount of seed. So that's the main reason for doing that test, is that they have information on the seed that they're buying, so that they can make informed decisions about planting rates.
The Iowa State University Seed Lab is part of the Seed Science Center. We've been testing seeds on the Iowa State campus since about 1890. And some things have changed in seed testing since then, some haven't. But we're an important part of the process of getting seeds from the field, or however they're produced, to the end user. Because the seeds have to be harvested, they have to be cleaned up. And so in the Seed Science Center, we've got a seed conditioning unit where it's mostly for training purposes, either for workshops or for class purposes. But it's the same thing that happens out in the seed industry, is where the seeds are harvested and they're conditioned to size them, to remove the light seeds, the dirty seeds, whatever. And then they're tested in the seed laboratories to determine the quality and the vigor of the seeds. And then if it's acceptable, it goes to the end user. And at the Seed Lab, we do the full range of testing, germination testing, vigor testing, purity testing, GMO testing, the works. So this is our purity lab, or some people refer to as a mechanical purity. And with the mechanical purity, you're separating a sample into the components as far as pure seed, weed seed, inert matter, and other crop. So this is something, the procedure's not changed in probably 100 years, is that someone that's very highly skilled to recognize a lot of different types of seeds will take a sample of seed, in this case it's crown vetch. And they're, one by one, they're going to examine those seeds and see if in fact they're really all crown vetch, or there may be some alfalfa seeds in there, or some weed seeds. And so they're handling about 2,500 seeds one at a time. The AOSA rules for testing seed, volume 1, has a table for purity, and it tells us for a purity exam how many grams of seed you need for each species and how many grams of seed you need for noxious. So it's just a matter of getting that amount of seed. We've got a general blower. In this case, we've got oats in the blower. So this one is not carefully calibrated because its purpose is just to remove the light material from the heavy material. So unlike the blowers to my left, they are calibrated. The only purpose for this is to put the light material up here and the heavy material at the bottom. And then the purity analyst has to go through that light material and determine whether they're seeds, because they might be seeds and they might just be light seed. These blowers we use with the uniform blowing procedure, which is in one of the volumes of the AOSA rules. And for selected species like Kentucky bluegrass, if we properly calibrate these blowers, when you blow a sample of Kentucky bluegrass, whatever blows out we consider to be inert matter. So the purity analyst doesn't have to go back through and squeeze every seed. What blows out is inert, and what stays at the bottom, that's what the analyst has to go through and check for the purity test. And so that's on a certificate of a bag of seed, or at least a large bag of seed. The two big bits of information are the purity information and the germination information.
Again, these tests are, ultimately designed to help the farmer buy quality product and make informed decisions about what they're planting.